Hi, it's Carly McAvoy. I'm doing word problems today, and when we're doing Pythagorean Theorem, you need to use the square root button on your calculator, or be able to do square roots in your head if they're exact. And so I just wanted to remind you about that. The square root of 25 is 5 because 5 to the second power is 25. So this symbol right here is called the radical symbol. And what the radical symbol is asking is, it's asking you the question, what number, if any, to the second power equals x? So if you take some number to the second power, what would the number to the second power that equals that? So when we have the square root of 144, we're saying what number to the second power would equal 144? And you might know that off the top of your head, that that's 12. If you don't know, you have a calculator available, and if a calculator is available to you, you have a square root button. Typically it's associated with the square button. See, just above this we have the square root button, and so to get to anything that's in blue like that, you're going to hit the second function button up there at the top, and then hit that button, and that will give you your square root, and then you could enter 144 and then hit enter. That is exactly 12, which is a perfect square. And then we could do the same thing with 400. What number times itself equals 400? And that turns out to be 20. But they don't always come out to be exact. And you might have, it depends on your calculator, but I wanted to show you, if you put this into your calculator, the square root of 12. This is not an exact answer, but if I just put 12 in there and hit enter, it gives me 2 square root of 3. And that's a great answer for certain classes and for certain things. If you're trying to find the length of something in our class, probably you just want a decimal answer. If you want the decimal answer, do the second function, square root button, put the 12, and then put a decimal point at the end. That's just going to tell the calculator that you want the decimal answer. And then you can see that's about 3.46. Not exact, because it's not an exact square, but for our purposes, let's say 3.464. And I could always use the approximation symbols in the front there. Okay, so that's how we're going to do square roots, and the next part is just talking about what is the Pythagorean theorem. So this is pretty small. A squared plus b squared equals c squared, and that is the two sides, the two legs are a and b, that they meet to form that right angle, and across in the right angle is the slope, and that's the hypotenuse. It's also written pretty small there, but you can see it written bigger up here. So a squared plus b squared equals c squared. I'm not going to do this justice, but I'm going to show you sort of the proof of this really quick. So let's say that this was 3, and this was 4, and this was 5. If you think about a squared, that is 3 squared, right? That'd be 3 times 3, and that would be 9. 3 squared is 9, and this would be 4. A square coming off of this would be 4 by 4, and that would be 16. And then if we could bring a square off of this one, that square would be 5 by 5, and that would be 25, and 16 plus 9 does equal 25. So the squares, the sum of the areas of these two squares is equal to the area of that square. That's all the Pythagorean theorem tells us, but we can use it for a lot of applications as you go forward in math. So if you're missing a side, we're going to continue to use this idea that a squared plus b squared equals c squared. So again, this is kind of small, sorry. This says 6 and this says 8, and so what I know is that the squares of these two sides equal c squared. So I can say 6 squared plus 8 squared equals c squared. I don't know what that is yet. 6 to the second power is 36. 8 to the second power is 64, and I have c squared. Well, 64 and 36 is 100, and this is where the square root comes in that we were looking at earlier. When you have something to the second power, you can take the square root of both sides to get c, which is what we want. We just want c, and the square root of 100 is 10, because 10 times 10 equals 100. So c equals 10 meters. It's not meters squared, it's just the length of a side. You might ask, well, what about when you take the square root of 100, you could get negative 10. Well, when we're talking about the length of a side, we never want to talk about the negative part of that, because we're not interested in negative lengths. Okay, this one's a little different because we have the leg and we're missing a leg, and then we have the hypotenuse. So if I set this one up, I'm going to say 5 squared plus b squared equals 13 squared. Because the b is what I'm missing here. You can't just say these two legs are going to equal that one. It always has to be the legs are the ones that meet at the square there at the 90-degree angle. So 5 squared is 25. And 13 squared is 169. Then I'm going to subtract 25 from both sides. And then I get 144. And we already saw what the square root of 144 was. To find b, we're going to take the square root of both sides and just get 12. So b equals 12 inches. And that one, we were finding the leg. Here we were finding the hypotenuse. And the last one, you're not given the triangle. If you might sometimes just be told, hey, leg 1 is 9, leg 2 is 12, or they might tell you a hypotenuse instead. When you know 9 and 12 are legs, those are the two sides that meet at the angle. So we know we're missing the hypotenuse. They should have given units here, but it doesn't matter. We'll make up units. Let's say it's centimeters. And then we have C. Okay, so now we know when I say they, I wrote this, so I should have given you units. I kind of acted like that was somebody else's fault. That was mine. Okay, 9 squared, and then 12 squared, and then C squared. Because the sum of the squares of the two legs equal the hypotenuse squared. So that's 81, and this is 144, and this is C squared. Now, I don't want you to think that you always get an exact number when you're finding a Pythagorean, when you're solving Pythagorean problems. So sometimes you get something like 12, the square root of 12. That's why we did that earlier. I set these up to come out nice, though. So I have 81 plus 144. And then that is square root of 225, and I know that that's 15, but I can do the second function of 225, and I get 15. So I have 225 equals C squared, and if I take the square root of both sides, I get 15 equals C. So C equals 15 centimeters, and that C stands for the hypotenuse. All right, have a fantastic day, and we'll see you next time.